In manufacturing, high-powered lasers are most often used in material processing, such as welding, drilling, and cutting, scribing and engraving, and heat treating of materials for hardening. CO2 and neodymium YAG lasers are the most common types. Their laser beams are often delivered to a target by robotics or optical components, such as optical fibers. Open beams most often occur when a beam housing is removed. A housing may be removed for a number of reasons: maintenance, service, power measurement, or aligning of mirrors. An open beam from a Class 4 laser may cause a hazardous reflection to project across the entire length or width of a room. If you have to work with an open beam, never directly view the beam. Use sensor cards that fluoresce or re-radiate the laser energy at a different wavelength from the beam. This allows you to safely view the beam through protective eyewear. When aligning open beams, reduce the power of the beam as low as practical. If at all possible, align a high-powered beam using a coaxial beam from a low-powered laser. Terminate the beam with a beam stop and use a temporary barrier to reduce the likelihood of projecting the beam across open areas. Tools cluttering the work area can create unexpected specular reflections. Make sure to put tools away. During maintenance or service, it may be necessary to access the laser beam. This requires the removal of protective housings and service panels, and the defeat of interlocks. After these procedures, housings and panels may not be correctly replaced, which means that a potential hazard exists for the equipment operator. During maintenance and service, use a temporary barrier to control errant beams. After completing maintenance or servicing, check that the interlocks and protective housing have been properly restored. Manufacturing is often a harsh environment for laser equipment. Work areas are sometimes dirty and cluttered. Dirt from cutting oils can infiltrate a laser system and cause the equipment to malfunction. Make sure the work area is clutter-free. To ensure that lasers are clean and operating properly, perform routine maintenance. When high-powered lasers are used to cut, drill, or weld metals, plastics, or composites, potentially hazardous airborne contaminants are generated. Evacuate airborne contaminants with an exhaust ventilation system. Over a period of time, system components may break or suffer damage. Labels may be removed or worn off. Emission indicators may burn out. Protective housings may be damaged. Parts from a system may be borrowed and not returned. Routinely check the laser system to make sure that components work properly, no parts have been removed, and that all warning labels are in place and the print is legible. Perform routine maintenance. Work with high-voltage systems produces the potential hazard of electrical shock or electrocution. To avert this potential, you should always follow good work practices. When electrical power is not required for maintenance or service, it should be shut off by following proper lockout-tagout procedures. For maintenance or servicing, capacitors must be safely discharged and grounded after the power is off to prevent accidental contact with stored energy. The best way to prevent accidents is to be respectful around lasers. Regularly inspect lasers used in a manufacturing environment to verify that all their safety features are functioning. Read the instruction manual and standard operating procedure for each laser and follow all procedures as written. Don't take shortcuts. With lasers, accidents happen at the speed of light. You will now view 3 scenarios. They illustrate laser accidents that can occur in manufacturing. This technician is using a CO2 laser to prepare the laser for material processing. The laser has an invisible infrared wavelength. This wavelength is hazardous to the superficial tissues of both the skin and the cornea. Why do you think this accident occurred? Be aware of the nominal hazard zone for every laser you work with. This information can be found in the SOP. Do not attempt to work with a laser until you know where you can safely work. This technician is using a CO2 laser. Its beam is invisible. He has removed all pieces of the protective housing from the laser system and is working with an open beam. The technician is within the nominal hazard zone, which for this job is permitted. Why do you think this accident occurred? Remember to put all tools away. They are potential reflectors of laser beams. At the operational wavelength of carbon dioxide lasers, even dull metal surfaces may serve as specular reflectors. Keep the area as clean and clutter-free as possible. This technician is performing routine beam adjustment on a neodymium YAG laser. The laser beam is invisible. Why do you think this accident occurred? It is your responsibility to make sure that your equipment fits properly. If there's a problem, see the laser safety officer before you begin working. Here are important engineering and procedural control measures for working with lasers in manufacturing. The best safeguards are protective housings and interlocks. If the laser beam and its reflections cannot be completely enclosed, other control measures must protect you. These include warning systems to indicate when the beam is on. The NHZ must also be identified and personnel excluded from the area by barriers or curtains. Anyone entering the nominal hazard zone must wear protective eyewear. The eyewear must attenuate the laser energy to a safe level and should fit snugly but comfortably. When a beam is open, you must define a restricted area and limit the number of people in the area to only those necessary. Post danger signs at the entrance to the controlled area. Only qualified and authorized personnel should operate lasers. Follow all standard operating procedures. These procedures should be written in consultation with your laser safety officer. In particular, they should identify all potential hazards. A complete standard operating procedure must also indicate the level of training required for the laser in question. The laser safety officer should conduct an annual safety audit. A safety audit ensures that technicians have the required level of training, that interlocks have been installed and are functioning properly, that the equipment is operating properly, and that all technicians are familiar with the standard operating procedures. Report to your laser safety officer any malfunction that could present a safety problem. Above all, know the laser you're working with.